Hey, hope you're doing well here today. Got a nice little, somewhat easy lesson today. Nothing too new, but something that will be very useful maybe for other things that you guys are doing in math here. And that is solving rational equations in one variable. Okay, so basically we have equations that have variables and fractions, and how is an easy way to solve it. All right. So the easiest thing to do, at least I believe, is to get rid of the fractions. Okay, so how do we solve equations with fractions? We get rid of the fractions. All right. And so to do this, you want to determine what would be the least common denominator of all the denominators in the equation. Okay. And then whatever that least common denominator is what you multiply both sides by in order to clear the fractions out. Okay. So you have to be careful to multiply every single term, not the ones that are just fractions. Okay, that's a very important thing. A lot of times people clear the fractions, but then they don't bother multiplying the other terms that aren't fractions. And before we determine the least common denominator, you should completely factor any parts of the irrational equation, okay? Because sometimes it will just cancel out how it is, all right? And you won't even have to bother with using that in the least common denominator. But always completely factor first, then that will help you find the LCD, the least common denominator. Alright, so let's start with this simple-ish one here. We have x plus 2 equals 15 over x. And so the least common denominator here is x. Okay, there is no factoring needed. So we're going to clear the x. In order to do that, we want to multiply both sides by x. Okay, so you see that's what I did here, and you have to multiply the other side by x here. And when you do that, you want to make sure to put these parentheses around these two terms, x plus 2, and that means we will be distributing in this x, okay, into those two terms, and we would end up with x squared plus 2x equals 15. Okay, so now you have a quadratic equation, and anytime you have a quadratic equation, I would suggest you set the equation equal to 0, unless it's a really simple quadratic equation like x squared equals 16, something like that. But set the equation equal to 0, try to factor it, and if it doesn't factor, use the quadratic formula. Okay, so I moved the 15 over to the other side by subtracting. All right, and so first thing I'm going to do is consider factoring this, and if that doesn't work, use the quadratic formula. So it does factor, I believe. Let's see, let's double check it. You multiply the outside, it's negative 3x. You multiply the inside, it's positive 5x. You combine 5x minus 3x, that's 2x in the middle. So yes, it does check. And after you factor it, you set the factors equal to 0, and then you get your two solutions like so. All right. Now, when you're solving a equation like this, that's a rational equation. It is very likely that one of your two solutions will give you a domain error, okay, which will mean you will be dividing by 0, and that solution will not be a true solution. So what you have to do is check for extraneous solutions. All right, so make sure neither of these results in a division by 0, but in this case neither does, because, well, you just have x on the bottom. So if we would have gotten x equals 0, that would be an extraneous or extra solution, okay, but neither of these are extraneous, so both of these would be your solution set, okay? So a lot of times you'll see the solution set like this with the numbers written in it. Oops, that's positive 3. Usually solution sets are written in decreasing, or actually increasing order, okay? So negative 5, 3 would be your solution set. All right, let's take a look at a slightly harder one here. Whoops, I got it all showing. Scaring you. Okay, so there we go. This one is a little bit harder because you should try factoring it first to figure out the LCD. So nothing factors with x plus 4. But here you have two terms. And how do you factor this? Well, always remember, the first thing you want to think about when you're factoring is a GCF. So you take out a GCF of x here. So you have x plus 4 left. And then that tells you that your LCD that you could use to clear the fractions out is the combination of these two denominators. Okay, you have x plus 4 in both of them, so that's going to be one of your factors. Okay, but you also have x, so you have to multiply by x as well. Okay, so this is just a side thing. The LCD is what you multiply the fractions by. Okay, so multiply the right side by x times x plus 4. That will cancel this out. Over here, you have to remember to distribute to even the 2 here. You have to distribute x times x plus 4. Okay, and when you distribute to the second term here, this fraction, all right, the x plus 4 will cancel out, but not the x. Okay, so it will look like this. Okay, so the 2 will have both factors, x and x plus 4. The minus 3 over x plus 4 will lose the x plus 4 factor because that will cancel out, but you will still have that x factor remaining. Okay, so you have to be careful to cancel out the stuff and distribute. You want to distribute, then cancel. You don't want to cancel, then distribute. Okay, a common error would be canceling these x plus 4s and only distributing the x, but you have to distribute first. All right, likewise, as before, we're going to try to get it's an x squared equation, so we want to try to get all the terms on the one side and set it equal to 0. So we do that, and now let's see if we can factor to get 5x. So we have 2x and factors of 12. Do any of these ones work to give you the middle here? Oh, look, I have it circled already. 2x times 4 is 8x, x times 3 is 3x, 8 minus 3 is 5. So this pair and 3 and 4 will give you 5. Okay, the signs are going to be different because this is minus 12 here. So we want to get a negative 12, so we're going to put different signs in parentheses. Looks like I didn't finish the problem. Uh-oh. I thought I did, but I guess not. So let's continue here. All right, so we would have 2x and x, and we want to make sure to get 8 minus 3. So we're going to put the, and we want to have more positive, so I'm going to put the plus 4 here. That would give me positive 8x, and then the minus 3 here, so I can subtract 3x. Okay, so that will give me the 5x in the middle. Okay, so now we need to figure out what x is going to be from each one of these factors. You get a 0. So from the first factor, you'd have 2x minus 3 equals 0. If you add 3, then divide by 2. This 0 would be 3/2. Okay, just a two-step equation. And this 0, x plus 4 equals 0, will give you x equals negative 4. So those are your two zeros. Now, are either one of them extraneous? Let's go back and look up here, and you see right here you have x plus 4 in the denominator. So if we substitute a negative 4 in, that will give you 0. So this one here is an extraneous solution. Okay, which means it's not going to actually work. So this is your only solution to this equation. All right, let's check out this one right here. Another one that's a little bit more beefy. Okay, so first, none of these fractions here will simplify. So what I'm just going to do is I'm going to take this and copy it down here. Okay, because guess what? None of this stuff simplifies. However, we can simplify x squared. No, we don't simplify it. We factor x squared plus 3x minus 4 first. Okay, so I'm going to factor this part. It's going to be x times x minus 4. Factors of that are 2 and 2, 1 and 4. So we know it's going to be 1 and 4 to give you 3. We have to have more positives. So I'm going to put plus 4 here, and then minus 1, okay, which happens to be the same factors as x plus 4 and x minus 1, okay? So what does that tell us? That means in order to clear the fractions, we need to multiply by the least common denominator, which is a combination of the two factors that you see on the left, or the same thing as these two factors here, x plus 4, x minus 1. And so that's what we're going to multiply both sides of the equation by. Okay, so if we multiply both sides by the least common denominator, You could do that if it's really long. That way you can cheat, I guess. Not really cheating. Just sake of time. That will cross off. Okay, over on this side, we're going to be multiplying by the least common denominator. Okay, the LCD. Okay. All right, so now you're going to distribute the least common denominator in. And for the first term here, the x plus 4 will cancel, but you'll have the x minus 1 left. So it'd be 4x times x minus 1. For the second fraction, 3 over x minus 1, the x minus 1 will cancel, but you'll have the x plus 4 left. So it'd be 3 times x plus 4. Okay. Now, on the right side, everything cancels, so you're just left with 15. Okay, so let's go ahead. We're going to do distribute that in. It'll be 4x squared minus 4x plus 3x plus 12 equals 15. Okay, so we're going to combine some like terms here, and so this would be negative x. We're going to subtract 15 from both sides, so 12 minus 15 is negative 3. All right, then we have to see if this will factor. So I went ahead and factored it real quick to save you time. The signs are different. X and 4x and 3, 1 work. Make sure that gives you negative x in the middle. You have negative 4x for the inside two multiplications, 3x for the outside, so that's more negatives, and that's negative 1x. Okay, now if you set each factor equal to 0, you get the first one being extraneous. The second one is negative 3/4. Okay, so remember why this is extraneous? It's because if you substitute it back in, you're going to get division of 0 here, 3 divided by 0. Okay, so that's a bad thing. All right, let's look at this next one here. All right, so once again, we should try factoring this first before we solve this one. Can we factor x squared minus 2? No. But we can factor the top, x squared minus 6x plus 5. And you want to see after we factor that, will that cancel maybe with the bottom here? So let's factor the top anyhow. It's going to be x minus 5. Factors of 5 are 5 and 1. Remember the signs here are the same because that's a positive 5. And they're going to be both negative because it's a minus 6 there. So x minus 1. Okay, so that would give you negative 1 and minus 5. So negative 1 and negative 5 make negative 6 in the middle. And you'll have x squared minus 2 equals 3. All right, so since nothing cancels, what we have to do here is multiply by the LCD, which is x squared minus 2. So we're going to multiply both sides by x squared minus 2. Okay? And when we do that, that will clear the x squared minus 2 there. And then we will basically, factoring here didn't really help us at all, so I'm just going to unfactor it, or FOIL the top back out, which will be the same thing as what we started with. Okay, x squared minus 6x plus 5. We're going to distribute the 3 in. It'd be 3x squared minus 6. Okay, now it's another quadratic equation, so I'm going to move all the terms over to one side, and then I'm going to see if I can factor to solve it. And guess what? You cannot factor it, so you have to use the quadratic formula. Here's the quadratic formula. Make sure you do opposite of b plus or minus b squared minus 4c all over 2a. And so if you use the quadratic formula, a is 2, b is 6, c is negative 11. Okay, it will look like this when you substitute it. You'll get 124 underneath the square root here. Then you just need to simplify things. Square root of 124, you could split into square root of 4 times 31. Square root of 4 is 2. Okay, so you have 2 square root of 31 for this part. And then you just reduce these fractions here. Okay, so negative 6 over 4 reduces to negative 3/2. And then here 2 over 4 reduces to 1/2. I got rid of the extra 1 there. And that's the simplified version of it. Okay, so, and remember you're solving for x. All right, so that's two values for x. All right, I hope that helps you with this lesson. And I'll post another Math Excel assignment. Hope you have a great day. Bye-bye.